Hello everyone, welcome back. I'm your friend in XO. Today, let's get into the lecture 2 of probability theories.
Axiomatic.
Axiomatic definition of probabilities, classical definition of probabilities, geometric definition of probabilities, statistic definition of probability. So,
Axiomatic.
axiomatic definition of probability. Let OZ be some system of sets A belong to the omega. Using the set theoretic operations U. Oh, to be honest, I don't know how to read all those symbols out there. Okay, when you see this, you say this symbol U9 of, intersection of. And how we do read this one, we say X bar. Alright, let's back into this book. We have some operations, especially
Set theoretic
operations. And we can build a new system of sets that are also events. By adding certain and impossible events to these events, we will get algebra. Therefore, algebra F is a system of sets such as empty sets, omega equal to the F. Omega belongs to F. F is closed under impossible and certain events. If event A belongs to the F, so the opposite or the A bar also belong to the F set. If A and B both belongs to the F set, then the union of A and B or the intersection of A and B also belongs to F. And here's another, let's say, another word.
Kolmogorov axioms.
But the length is not important at all. Let's say, let simple space omega be a finite set of elements W which are called elementary events. F be a set of all subsets of omega. The elements of F are called events. For any event A, there is a non-negative number probability of A, which is called the probability of event A. The probability of event omega equal to 1. That's all those probabilities out there. If events A and B are disjoint, then probability of A plus B equal to the probability of A plus probability of B. There's a word called disjoint.
Disjoint.
Of course, if they are the same, let's say if they are not disjoint, we cannot use this let's say formula. And they also point out the, let's say, classical definition of probability, which is, okay, if you got a whole of probabilities like P omega, probability of omega, that's all probabilities that you have, then you define an event, and there's an event called even number of points occur. Then what's the probability of A? What's that? It's equal to the point of A events divided by the points of all events. This may be not intuitive for you to understand, but we also have a geometric definition of probabilities. For this one, that would be much more easier for you to understand. For example, what's the possibility of one point that was located on the area of G let's say the lowercase g than the capitalized of G? What's the probability of that? Will that be just equal to the lowercase g's area space divided by the capital area space? Something like this. And for this event, for the A event, it's a point falls into the domain of lowercase g, which is this one. I guess you already know that very long ago in your school, back into the school. This is not, let's say, so hard for you to understand it, right? I guess you probably learned it in the primary school. I don't know. And here even comes to a difficult one. Statistic definition. I don't know if I'm reading it correct.
Statistical.
Statistical, alright. Statistical definition of probability. long-term observation of occurrence or non-occurrence of event A with a large number of independent experiments performed in the same conditions. In some cases, shows that the number of occurrences of A obeys stable laws. We will consider the frequency definition of probability as it is the one that currently is most widely held. To do this, we need to define two concepts. One, sample space S, and two, relative frequency. One, sample space S is a collection, sometimes called universe of all possible outcomes. For a stochastic system, what is that?
Stochastic system.
Stochastic system, alright. For statistical system or an experiment, the sample space is a set where each outcome compromises one element of the set. And the second one is relative frequency is a proportion of the sample space where an event A occurs. In the experiment with 100 outcomes, where A occurs 80 times, the relative frequency is 80 divided by 100 or 0.8. Oh, okay, so this is also, let's say, quite easy for you to understand. For example, if let me say I don't know how to express it in English, so I'm gonna do some search.
Buy lottery tickets.
Alright, if I buy lottery tickets, if I buy, let's say, 100 of that tickets, and it turns out if there has 80 times that I win money, then I would say the possibility for me to win money is 0.8. Okay, the concept for this is quite easy for you to understand, but I don't know why he used such an complex formula to describe that behavior in a mathematics way. But it says that the best way to illustrate this is an example experiment that we run many times and measure the
Cumulative.
Okay, we run that experiment many times and measure the cumulative relative frequency, which is say RF. You know, I always think that the short length for a whole sentence is not good for modern life, because this short length could mean a lot of things. You don't know which one is the correct one, but if you say this one, cumulative relative frequency, you will easily understand what's going on, what they are talking about. So, and in modern computer, the computer doesn't care if you use this long sentence or this short sentence. But for human, we perform this long sentence. So why don't we just use the long sentence? The cumulative relative frequency. The cumulative relative frequency is simply the relative frequency computed cumulatively over some number of replicates of samples, each with a space S. We have, if the limit exists, probability of A equal to the limit n to the infinity, where we calculate the probability of A over the n, the sample n. Yeah, I'm so happy that this lecture is actually not that long. We just spend, let's say, a few minutes, maybe 10 minutes, then we finished that lecture. That's good. I don't want to overreading. I don't want to get overreading by those materials at a short time. We'd better learn something little by little than doing it all over a short time. That won't be good for us. Okay, then this is this video, and I'll see you guys in the next one. Bye.